Okay, I'll start one more time. Cross your fingers. Okay, this lesson 1-4 is about solving equations. So far we've just been working on mathematical expressions, but when you put an equal sign in an expression like 2x = 10, now you've got an equation. So I just remember the root word equation, equal, right? That's how I remember. So we're going to learn today how to solve equations and to solve the problems by creating our own equations. So our bell work today is this picture of this mobile. It says you bought a mobile kit. You read on the package that the weight of the entire mobile is 40 ounces. Each inch of the crossbar weighs 1 ounce. What is the weight of each shape? And justify your reasoning. Okay, so I would like for you to pick a partner. Don't move till I get attendance here. But if you don't have anyone at your table, let me get attendance and then I'll let you move. So I'm going to pause the video. Actually, I'll pause the video the whole time. I'm going to give you 5 minutes to work on this. But let me give you a push start on this. So if it tells you this whole thing is 40 ounces, and it tells you that each crossbar, each inch of the crossbar weighs 1 ounce. Well, if this is 40 ounces and this is hanging evenly, then doesn't it mean that this side is 20 ounces and this side is 20 ounces? And if each inch of this bar is 1 ounce, well then we're going to have 20 minus, we have 4 inches here, so there's 1 ounce, 2 ounce, 3 ounce, 4 ounce. So this shape must be 20 minus 4, okay? And use that methodology to solve the other side, okay? And you can work with the partner. I'm going to pause the video now, but I'm going to give you 5 minutes to solve it all, and we'll come back. I'm going to pause the video, so if you're watching the video, pause now. Okay, so now that we're coming back to this, we did decide that this shape is 16 ounces because you divide it in half. The whole thing's 40 ounces, divide it in half, take off the 4 ounces for 4 inches of the crossbar, so that's 20, which is half the weight, minus 4, which is 16. So we know this first shape is 16 ounces. Now that means that this whole side is also 20 ounces. Well, take away the 4 ounces here, so we know that these must also be 16. Everybody see that? Okay, now let's divide this in half. So half of the 16, that means that this side is 8 ounces and this side is 8 ounces. So let's do the more simple side right here. So if this is 8 and we've got 2 inches of bar, then this weight of this yellow shape is going to be 8 minus 2, which is 6. Okay? Then that means that this side is also 8. Well, take off the 2 inches for this bar, so we're down to 6 ounces, and then divide it in 2. So 6 divided by 2, well, we're going to have 3 over here and 3 over here. Well, 3 minus the 1 inch of bar, because that's an ounce, 3 minus 2, or 3 minus 1 gives us 2, and 3 minus 1 gives us 2. So there's all your weights, 16, 2, 2, and 6. Any questions about that? A nice little piece of chewing gum for your brain to get it warmed up for equations. And when we think of an equation, I said there's an equal sign, right? So if we have an equal sign somewhere, and I say that this side, whatever it may be, is equal to this side, Well, if we were to put this on a scale and let it just chill out, it would lay perfectly level, wouldn't it? What would happen if I added 2 things to this side? Say, this is 5 pounds and I just added a pound and a pound. So what's going to happen to this board here? Is it going to tilt? And it's going to tilt this way, right? And this side's going to move up because there's more weight on this side, right? So to keep it equal, what would I have to do? Add 2 pounds to the other side, and then it would level back out, wouldn't it? So that is the whole purpose of equations. You've got this equal sign. Whoops, didn't mean to do that. You've got this equal sign. So whatever you do to one side of the equation, you must do the same thing to the other, okay? Whether it's add, subtract, multiply, divide. Any questions about that? Okay, please remove your earbud. And that goes for anybody who's got an earbud in. Okay, not many times do I have to ask that in math class, nor will I. All right, so here's some examples of equations. So here's an equal sign. I always scope out, like an eagle or a hawk looking for a mouse out in the field. I scope out those equal signs. And then I know, okay, there's my starting point. What do I have? On this side I've got this, on this side I got that. Then I start looking at, okay, well, how do I solve this? All right, so on this equation, we've got an equal sign here, and we've got x over 3 is equal to 30. And our equal sign here is there. That means that this side, 2y minus 1, is equal to y plus 11. So just picture that pendulum, or not pendulum, the pivot, fulcrum, it's the fulcrum, sorry, and the board. So right now they're totally equal. And whatever you do to one side of these, you have to do to the other to keep it equal. So again, the formal definition of an equation is just a statement that 2 expressions are equal. In this lesson, we're going to use equations to model and solve problems. There's many properties of equality and inverse operations that we're going to use to solve these. And these are things that are just review, so I'm not going to spend a lot of time, but if you want to watch the video at home, pause and read over these, you may. But we've worked with the reflexive property that just says a is equal to a, 1 is equal to 1, 5 is equal to 5, infinity is equal to infinity. Symmetric means if a is equal to b, then b is equal to a. So if I say that x is equal to 5, then I can also say that 5 is equal to x. It's the same thing, symmetric. Transitive, that's when you have that thing that says, well, if a equals b and b is equal to c, well, therefore, a is equal to c, right? You can knock out the middleman. And then substitution, if a is equal to b, then you can replace a and b and vice versa. So, that gets us into one-step equations. So let's look at a one-step equation and we'll look at how we solve. Before we do that, I want to show one more page here. I just put these up front to get them out of the way. Addition, subtraction, multiplication, division. These are things you've done since elementary. But now we're putting proper definitions to them, and we have some examples. So sometimes we're going to use addition to solve an equation. Sometimes we'll use subtraction. Sometimes we're going to use multiplication. And sometimes we're going to use division. So we can use all these things to solve equations. So our goal is if we have, say 5x equals 10. I think that's the one I've been using all day. If I have this, to get a solution for this equation, I'm going to have to isolate this x. It means, what does x equal? How do I solve this equation? You get it down to one variable equals something. So, and that's where your operations and inverse operations come in. Well, you're going to have to use the inverse. To isolate this x, I've got to get rid of the 5. Well, 5's being multiplied to x, right? So the inverse of multiply means the opposite of multiply is to do what? Divide. So to get rid of this 5 that's multiplied to x, we have to divide by 5, do the opposite. And if I divide this side by 5 of the equation, the equal sign, I've got to divide this side by 5. Then these cancel out because 5 over 5 equals 1. And we're just left with 1x, or x, which was our goal, to isolate x, equals 10 over 5, which simplifies to 2. So our final answer is x equal 2. So that's how you solve an equation using inverse operations. Now that was just one step to get to that answer, so they call that a one-step equation. If it takes you 2 steps to get to the answer, they call that a 2-step equation. If it takes you many steps, anything over 2 is just called a multi-step. So 1-step, 2-step, multi-step. This is a 1-step. So if I have x plus 4 equals negative 12, let me do this. We're going to say x plus 4 equal negative 12. Was that right? Or did I make a transfer error? Yep, that was correct. Correct. All right, so to solve this, I need to isolate the x on this side of the equal sign. And there I've scoped out my equal sign right there. I'll put it in bright pink. There's my equal sign. I will often put like channels or bars coming down as I solve things to remind me, oh yeah, that's where the equal sign goes. This is what separates the sides. So I call that my river of equality. So to isolate x, it means we've got to get rid of the 4. And right now we're adding 4. So the opposite, the inverse operation of add is to do subtract. So we're going to subtract 4. And if I subtract 4 from this side, I must subtract 4 from this side. All right, so let's put a bar under it. So positive 4 minus 4, that goes to 0, right? And then carry down your x. So we've got x plus 0 equals, carry down that equal sign. Now negative 12 minus 4 adds up to negative 16. So now we've got our answer, but it's pretty messy. Let's just clean it up. We don't write plus 0. That just disappears, right? Our answer becomes x equal negative 16. Now we have solved our equation. So how do you know if you get an answer right? What if you're not sure? Well, go back to the original equation and plug that number in and see if it makes a true statement. So negative 16. So let's go back to x plus 4 equal negative 12. And we said that x was equal to negative 16, correct? So let's plug in negative 16 for x and see if it makes a true statement. When we're checking for correctness, always put a question mark up there to say, hey, I'm just checking this answer. So you do an equal above, a question mark above your equal sign. So negative 16 plus 4 comes out to negative 12. And negative 12 does equal negative 12. So yes, this checks. That means that we've proven that our answer is negative 16. Any questions so far? Okay. So let's look at the second problem. What is the solution of negative 27 plus 6y equal 3 times the difference of y minus 3? So I think I have this blown up right there. I can make it bigger. Boom. Ignore the question mark. Don't yawn. That makes me yawn. That was, excuse me, that was very rude of me to yawn. All right, so the first thing we need to do is find our equal sign. Aha, there it is. So I'm going to make my river of equality here. Boom, boom. And now I'm going to look at each side. Is each side simplified? Yeah, he's simplified. No, he's not. Because I can distribute this 3 across those two terms, right? So let's do that. 3 times y is 3y. And 3 times negative 3 is negative 9. Now we've simplified this right side, and I'm just going to copy down the left side, negative 27 plus 6y. Now I have to decide, how am I going to solve this? I'm going to put the variables on the left and all the numbers on the right. So that means this y stays here, and this y I've got to move over, right? So I'm going to solve this by combining my y's. So I've got to get rid of this one, so I've got to subtract 3y. And if I subtract it from this side, I must subtract it from this side. And that goes to 0. And I can carry down the negative 9. Right? So I've got 0 minus 9. My equal sign, keep carrying down. So now let's do this. 6y minus 3y. They're like terms, so we just do the 6 minus 3y, which is 3y. And I'm going to carry down the negative 27 plus. The next thing I want to do, I'm still trying to just isolate my y. So I'm going to try to get rid of that. So the opposite of subtract is to add, right? So I'm going to add 27 to each side. All right, so this goes to 0, and I'll carry down my 3y equals, so I still have my river of equality there, and now I've got 27 minus 9, which is 18. And I'm getting closer, so I still just need to isolate this y. I need to get rid of this 3. So it's multiplying together right now, so to get rid of it, I'm going to divide by 3. And if I divide that side by 3, I must divide that side by 3. Now those cancel out. I have y equals 18 divided by 3, which is 6. And that's our answer. So that's a multi-step equation. Many steps to get to a solution. And there's many ways you can do it. Like if 5 of us solve it, we might all solve it differently. But in the end, we should all come up with y equals 6. Okay, does anybody have any questions about those? All right, let's move on to the word problems. It says you've got this beautiful event that takes place out in Brussels, Belgium. Flower carpets incorporate hundreds of thousands of brightly colored flowers, as well as grass, tree bark, and sometimes fountains to form intricate designs and motifs. The flower carpet shown here from Grand Palace is in Brussels, Belgium, and has a perimeter of 200 meters. What are the dimensions of the flower carpet? Well, they tell you the whole perimeter is 200, so you've got a perimeter. You know that, that's given. But how do you decide what x is? What are the dimensions? You have to know x to know the dimensions, right? So we can call this our width, and we can call this our length, or you can reverse it if you want. But we could say the width is x. It's hard to see, but right there, we'll say that's our width. Here, let me use darker. Width is x, and we'll let our length be 3x. So, and we know the perimeter is equal to 200 because they gave us that. So if we use the perimeter formula, we know that a perimeter of any square rectangle is just 2 times this side and 2 times that side, and add them together, right? So if this is x and 3x like they gave us, we know that the perimeter is what goes around it, right? The length of these sides. So x plus 3x plus another x. So that's what gives you the 2x plus 3x. And if you call this the length or width and this is the length, then what do we say? We say the perimeter is 2 times the length plus 2 times the width. Well, our length is 3x, and we know the perimeter, they gave us the perimeter, they said it was equal to 200. So substitute 200 equal 2 times the length, which is 3x, plus 2 times the width, which is just x. Sorry, that's running into each other. So let me write it nice and neat here. 200 equal 2 times 3x plus 2 times x. So that was your, let's see what I do, that was the length, and there's your width. And that was your perimeter. Alright, so let's solve it. 200 equals, well, 2 times 3x is 6x, and 2 times x is 2x. Now, look at each side of your equation, and we have like terms, right? So 6x plus 2x is just 8x, right? When the variables and the powers match, and they do here, because that's just to the first power, which is just understood. We don't write those. So variable and power matched. So we can combine, using the mathematical operation, add the coefficients of those variables. So 6 plus 2, that's 8x, equal 200. All right, so now we've got a one-step equation now. So what do? The opposite of 8 times x, we need to get rid of the 8, so we need to divide by 8. And if I do that side, I must do this side. So now that cancels out. So we have x equal, let's see, 8 goes into 20 2 times with 4 left over, and 8 goes into 40 5 times, and we're done. So x is equal to 25, but that's not what they ask us. They ask us the dimensions of this garden. Well, if we know x, we can tell them the dimensions, right? So let's go back to the original. So if x is 25, that means that this side is 25 meters, and this side is 3x, which is 75 meters. So we can say the dimensions are 25 by 75 meters. Any questions? So we just used the perimeter formula to solve, and it's a lot more words than it was work. If I was truly working this, I would have been done in about a fifth of the time that we sit here and talk through it. So don't let the words mess you up. They give you everything you need. They're actually easier than working problems that they just throw at you, because you have some understanding about what's going on. So if an equation has one solution, it looks like this. We've been solving things that have one solution. We get it down to x equal a number, or y equal a number, or z equal a number. It can be any variable, but it equals some number. That means that one number is its only solution. So that's things with one solution. Well, we're going to learn that some things can have many solutions, and others can have no solutions. So how do you do this? So if I'm solving, say actually let me see what this one is. This will work. Alright, so let's look. Let's solve this problem here. Here's our equal sign. So I'm going to put my little river of equality there. And I'm going to simplify each side. So combine like terms. 11 minus 7 is 4. And then carry the 3x equals. And on this side, we've got like terms, 6x minus 3x, which combines to 3x, and carry your plus 5. All right, now let's solve this. I'm going to put the variables on the left and the numbers on the right. So I'm going to start by getting rid of this 3x. So I'm going to subtract the whole 3x because I need it to go away. And if I do it from this side, I must do it from this side. So let's do that first. So 3x minus 3x is 0. Carry down my plus 5 because that's left over. I'm just carrying it straight down. And then 3x minus 3x, well, that one goes away too to 0. And I'm just left with this 4 and my equal. So I end up, let me clean it up, 4 equals 5. Is that a true statement? Does 4 equal 5? No, it does not. When your variables go away and you're left with a false statement, there is no solution. It's never true. There is nothing you can plug in for x that would ever make that a true statement. So, no solution. Never true. Okay? So when the variables go away and it's false, like 20 equals 15, 20 equals 20 and a half, false statement, it's no solution. Any questions about that? Now what happens if your variables go away and it's a true statement, like 5 equals 5? Well then, that's all solutions. Any number we plug in there will work. So if it's a true statement, it's many solutions, infinitely many solutions. Anything you plug in there will work and be a true statement. So let's look at this guy. Here's our equal sign. So now we have 6x minus 2x, combining like terms on each side of the equation. Right? So 6 minus 2 is 4. So we have 4x plus 5 equal, and over here I've got a 4 plus 1. That's going to be a 5 plus 4x. So just simplified by combining like terms on each side of the equation. Now I'm going to try to put my variables on the left and my numbers, everything else on the right. So let's get rid of this 4x. So subtract 4x, subtract 4x. And let's do that first. So that goes to 0. And that one's going to go to 0. So let's carry down what's left. 5 equals 5. Is that a true statement? So there it is. You've got anything you plug in will work. So it's infinitely many solutions. It's always true. Always. Okay? Any questions about those? So one solution, no solution, infinitely many solutions. Okay, let's move on.
Is there any way you get an equation to where it's like sometimes right and sometimes wrong, depending on what number?
No, it will either be right all the time or wrong all the time. It's either going to be true or false. Yeah, you're not going to have a case where it falls in between. So you're going to have one, infinitely many, or none. Okay, does that make sense? Okay, did that answer your question?
Yeah.
All right. I guess I should have shut the door. Okay, look at this next problem. The hallways are warmer than our rooms right now because the outside air is coming in. Oh, and if you see these dry erase markers get knocked on the floor, please pick them up and put them back on the table. If they're on the floor, they usually sweep them up and throw them away, and we won't get a lot more markers, so we got to conserve them. All right, a literal equation. So we're moving good. So a literal equation is an equation that uses at least two different variables. And when I think about how do you remember that word and how do you remember what it is and what it means, because you hear all these new terms in Algebra 2 we're throwing at you. And really, you've heard them before. This is from Algebra 1. So how many of you heard this in Algebra 1? Did your teacher teach you literal equations? Anybody remember them? Nobody? Oh. Okay. So let's look at what a literal equation is. When you have a literal equation, think of the word literal. It comes from think of words that sound like that. Literacy. What do you think of when you hear the word literacy? Literacy. What does it mean? What? Letters and reading. Exactly. Letters and reading. And that's literacy. And that's the root word. Literacy, literal, literature. You think of books, reading, letters. So when you hear that literacy, literal equation, it means it's going to have more than one letter in it. So if I have x plus y equal 15, I'm going to say this is a literal equation because I don't just have one variable, I have two variables. Anything more than one variable is a literal equation. We could say two or more variables, it's a literal equation. So if I had x, y plus z equal 15, still a literal equation. If I have z equal 15, not a literal equation because it only has one variable. Okay? So literal equation just means I am working with more than one variable. Everybody good with that? Thumbs up if you understand that, thumbs down if you don't. I need to see all thumbs, up or down. Very good. I love thumbs up. All right, so on your whiteboards, everybody write this equation. Let's do 2x minus y equal 30. Okay? Oh, if you don't have a whiteboard, just grab one off a table that's already there. So. Or you can get it from back there too. I bought new baskets for all the tables, so they're just still out in my car because it was raining this morning. So we'll be able to keep everything on the tables. And Dollar Tree loves me now because I bought so much stuff there last night. Ugh. Who doesn't love the Dollar Tree, right? I found everything in the world that I need there. Almost. All right. So write this down. 2x minus y equal 30. Now, this is a literal equation. And I want you to work with this. I'm going to tell you, and what you're going to see in these problems, it's going to be something like, let me make sure I get the wording right. What is x in terms of y? Let's write this down. What is x in terms of y? So here's the key. When they say what is, look at what follows that, x. So when they say what is x, that means you're going to be saying, oh, well, x equals, that's your goal, is to get this equation and x equals and everything else over there. Okay, so that's your key. When you see what is x, you're looking for an equation that's x equal. So if I was doing, I didn't even know what this is, but I remember that rule, what is x? Oh, it's going to be x equals something in terms of y. Well, if I was doing multiple choice and I had a x equal this and a z equals this and a f equals this and y equals this, well, I wouldn't even have to know any further. I could just say, oh, when it says what is x in terms of y, oh, when I see what is x, it's going to be x equals. So right off the bat, I would know, oh, it's got to be this one because that's the only one that's x equals something. So hopefully I've driven that point in pretty good. So let's now work towards that goal. What is x in terms of y? So it means at the end of this, I'm going to have, didn't mean to do that. I'm going to have x on one side of the equal sign and everything else, this 2 and the minus y, is going to be on this side of the equal sign. Okay? So let me write the let me write it again right here. 2x minus y equal, was it 30? All right. So our first step is, I always like to just circle what I'm going to leave. What are we solving for? I'm going to leave that alone. So that's the x. The x stays. Everything else on this side of the equal sign has got to go on the other side of the equation. That's solving for x in terms of y. So the first thing we're going to do, I look at this like friends, and they're in a car on this side of the equation. These guys, 2 and x, are hugged up real close, so we're going to let them just tug it out a little longer and get rid of that oddball friend sitting in the back seat. He's a little further away. You see that? So get rid of your oddball friends. If they're hugging up close, do that last. Let them hug a little longer. And get rid of the oddball friends. So I'm going to get rid of my tag-along friend, Mr. Y. So the opposite of subtracting y is to do what? So let's add y to get rid of him. And if I do it to that side, I must do it to this side. All right? So now that's done. He's gone. Now let's just carry everything down. 2x equals, and I'm going to do 30 plus y. Okay, we're not done. I'm going to circle, we're solving for x. So I still have to get that x isolated. When you solve for x, it has to be isolated. So now we've got to separate the date. They're hugging it up, so we got to divide them. So divide by 2. And if I divide this side by 2, it means I have to divide everything on the other side by 2. So you could do it like this, put it in parentheses and divide by 2, or you could just do it like this. Divide by 2, and any other term that was over there, divide by 2. I tend to do it like this. Divide everything by 2. Now this cancels out, and I have now solved for x in terms of y. So x equals 30 plus y all over 2. And you can leave the parentheses if you want or take them away, as long as you get that bar over under all of it. So do you see why they say we solve for x in terms of y? See, when we solve for x in terms of y, it means we have some y terms in that definition of what x is. Do you see that? In terms of y. So solve for x in terms of y. That means in terms of y, we've got y terms in his definition of what x is. So does that make things a little clearer about what is a literal equation? Now what if I said, okay, now take this and let's solve for y in terms of x? You would go, oh, we just did it the other way around. But we could do it. So let's solve for y in terms of x. So that means now, let me rewrite my equation. X equals 30 plus y divided by 2. So now I'm solving for y in terms of x. So the first thing I have to do is get rid of this division 2. So the opposite of divide is to multiply. So we're going to multiply this whole side by 2 and this whole side by 2. And then that, whoa, I didn't mean to do that. Oh. There we go. There we go. Okay, so that goes away and this goes away. They cancel out. So now I'm just left with 2x equal 30 plus y. Now I'm still solving for y in terms of x. So I have to get rid of this 30. So I'm going to subtract 30 from each side. And those 30 terms go away. Now I'm going to carry down my y equals, and now those are not like terms, so they can't be combined. So I'll just rewrite it, 2x minus 30. Now I solve my literal equation for y in terms of x. And that's all a literal equation is. You're not trying to get it down to y equals a number or x equals a number. You can't until they give you values for x or y. Now if they said x equals 2, now solve your literal equation, well then you would go, oh, well if x is equal to 2, I've got 2 times 2, which is 4. Negative 30 plus 4 is now a negative 26 equals y. Okay, I can solve it to a number, but they usually don't do that. When you work with literal equations, you're just getting it down to another formula. Okay? That's why they say y in terms of x. So the example they gave us, and I'm not going to go through them because I took so much time on that. They gave us the conversion formula for centigrade to Fahrenheit. So it was just a little bit harder. But there's one thing I want to point out. If they do give you a fraction, like c equals, let's say 3c equals 2/3 y. That's not what it is. But if I ask you to solve this for y in terms of c, well, you've got to get rid of this fraction. How do you get rid of fractions? Does anybody remember? Multiply by its reciprocal. So flip it. So multiply by 3/2. Just flip the numerator and denominator, and then you would multiply this whole side by 3/2. And they cancel out, because 3 times 2 is 6, 2 times 3 is 6, and 6/6 is 1. That's how it goes away. All right, so that's everything, guys. Thank you. And tonight, your work, if I can get to it, you're going to work 1-4, all the even problems tonight. Oh, and I need to take up yesterday's assignment. So pass up your 1-3. And we'll turn this one in tomorrow, 1-4 tomorrow. The evens tomorrow. All right, thank you. This concludes our lesson, hun.